Hey guys, ScannerDanner here. Today I am super excited to be with you because my son Caleb Danner is back with me. Thank you, Caleb, for being here. Cameraman Caleb, who's been MIA for the past couple of months, you know, with finishing up high school and being in the musical, the lead role, I should say, in a musical in high school, which is crazy work that he had to put in. But anyway, Caleb is here with me. I am at Danner's Automotive, and we are working on a 2015 Kia Sportage that is actually a friend of mine. He called me and told me that his air conditioning is not working, and I think he tried to add some refrigerant, which is not a good idea, especially when you're not sure if it's even low on refrigerant. So we might be overcharged. You got to remind me of that, Caleb, when we're finished here, that we might have an overcharge situation once we get this air conditioning working. But in any case, I believe the clutch is not engaging, and this is most likely going to involve the scan tool, which I have hooked up already. But before we do the scan tool and check for codes and things like that, I think let's do a couple preliminary checks that would apply to any AC system, and then we'll go from there. All right, we're still getting used to the lighting in the shop. This is a little bit tough here, but I'm just gonna do some checks inside to see how the climate control panel reacts to pressing the AC. All right, so pushing the AC button, it doesn't even light up. It doesn't even light up. Well, maybe it would help if I turned the blower on. All right, so hang on. Did I hear that clutch? Why can't I turn it off?
Turn the blower off.
I should be able to turn that off though. In the vent floor, or floor mode, I can't turn the AC off. Okay, that's why in the max AC mode, that's why I couldn't turn the recirculated air off, because max AC recirculates inside air. All right, so that's why that one wouldn't work. Interesting. Okay, in the max AC mode, I heard the clutch engage.
I could hear it too.
In the max AC mode, I can't turn the air off. You see that? Mm-hmm. But in the defrost, you can, because in defrost, you have the choice of outside air only in defrost. Notice it turns the I guess you can change it. Okay, I'm just getting familiar with the gauges or the panel here, but I did hear the clutch engage. Let's see what kind of, it's cold too. What are we doing?
I feel it.
What are we doing? So definitely in a case like this, well, right now the AC is working. I heard the clutch engage, my air is cold. I'm gonna call the owner. Well, let's see what we're doing here. Just stay right here.
Good afternoon, Mr. Danner.
Hey, Tim. Hey, you're on camera, just so you know.
Oh, I am?
Well, your voice is on camera.
Oh, okay, great.
Listen, I want to know what I'm doing here, because the air conditioning's working right now, and I thought you told me it wasn't working at all.
It'll get cold, and then it'll go hot.
Okay, so it does work for a period of time?
It has been, but not when it's hot out.
So if it's hot outside, like when you first get in it, it won't work at all?
It won't work at all, no.
Okay, so it's intermittent. And then when it is working, you can be driving down the road and then it stops working, yes?
Just blow hot air, yes.
Okay, and did you add refrigerant to this? I thought I heard you tell me.
I did add refrigerant to it. I had no gauge to put on there to see if it was good or not. I just pumped some into it.
How much?
It was, probably about 8 ounces.
So we're probably 8 ounces overfilled, I'm guessing?
Very well could be.
Okay, and that didn't change any of your symptoms? You had the same symptoms before and after?
Yes.
Okay, gotcha.
Yes.
Okay, well that at least gives me something to go by. Then I'm gonna hopefully find some fault codes related to the system and have some direction. Other than that, I'm gonna have to try to recreate it. So, but that helps me. Thank you, Tim.
You're very welcome. Thank you.
All right, buddy. Bye.
Bye.
All right, did you catch that, Caleb?
Yeah.
So
So we just wait for it to.
Well, we do, but let's
working.
as far as other preliminary checks that we can do would be to go under the hood and take a look at the clutch itself and see it engage. And so we'll get a shot of that for you guys. Most of you know this already, but let's show it anyway. You see how the front face of that right now is turning?
Yeah, I can.
Yeah. All right, I'm gonna turn the air off and on. So that's with it on. Here's with it off. And then I'm going to turn it back on. Did it change?
No.
Stayed engaged?
Yeah.
Hold on. All right, that's off. Did it re-engage?
No, it's just sitting there.
Tell me when it does. Should. Why is it not turning back on? I mean, we've now recreated our fault.
Yeah.
All I did was turn it off and back on.
You did turn it on.
Yeah. Yeah, it's not turning back on now. Yep, my air's warm. Well, okay. Back up to me. We at least got to see the front face of the clutch. You saw that spinning and you saw it shut off, right, Caleb?
Yeah.
All right, and now all I did was go back in and turn the AC on and off, and it's not turning back on. So I want to scan this system for faults and let's see where this takes us. I could do a full system scan, but if I have auto AC, that's really what I'm interested in. No communication. That's not cool. That's not cool.
What are you trying to communicate with?
The climate control system.
Nothing?
No comm. Error code. No communication. All right, let's see. Let's go back. I'm going to do a full system scan now. Key on, engine off.
I believe most people are good.
I should have got a shot of that.
There's no way you could hear it.
All right, so I just did a full system scan and I've no codes in anything. Could be with the climate control, because I was given the option. That's auto AC. This is not an auto AC system. Maybe that's why it was a no comm. Let me look again. If there's an auto button, so an auto would be like mom's car, Caleb, where it has a temperature that you dial in.
Yeah.
So a climate control system that's manual or auto, the way you determine that, well, number one, if you had an auto button, and number two would be if you have a temperature that you dial in like a specific degree, where this has just a cold and hot. I'm pretty sure this is a manual AC system. Yeah, this is not an auto AC, so we have no fault codes to go by, but I have a compressor clutch that's not engaging. Sometimes the clutch goes bad on these and you can do a quick tap on the front of it and make it start spinning again, which that's the low-tech way. The alternate way, and where we're going right now, because the scan tool is really not going to help me, at least not at the moment, is going to be that we do some checks at the relay. And we've done some of these systems before, Caleb, in the past. In fact, we have a video that's unedited on a Mazda, I think. And it's the one where I was wearing one of my new shirts. It was a gray shirt and it was like 95 degrees and it was disgusting. I sweat like all through my shirt. And we haven't produced it because it's disgusting. Nobody wants to see me in that shirt, this big sweaty guy. And it's a good video. I mean, eventually we're gonna get to producing it, editing it. That's like a year old, still sitting in the database. But we've done these before is my point, and where we go through the relay, we go through clutch checks, and that's probably the method we're going to be using on this. Let's try the low-tech way first. This can be a little bit sketchy, but let's try it. All right, starting this up, Caleb. That just turned on, didn't it?
Yes, it did.
Son of a bitch. All right, so now I need to try to make it quit again. Okay, that's off. That should be back on. And that does sound funny. The clutch is kind of noisy. That's off. Of course it's working now.
Yeah, it's done. Oh, dude, this is one of them internally controlled ones. I just did one on one of these. There's two different.
No external wires.
There's the external wires go through like a pressure switch on the inside, and they're internally controlling the.
But it still has a clutch.
Yeah, but it's not done with just a clutch hub. It's like in the compressor.
No, no, it's not. It has a front clutch face. You're talking about the variable swash plate ones with no clutch. This has a clutch. This has a clutch.
I know, but I just wait. Oh no, it does have a clutch. See, this is the one I just did on a Kia, and it doesn't wire directly to the clutch.
Oh.
It's controlled internally by that.
Okay, gotcha. But there still is a clutch face to it.
Okay, so you don't. That's the expensive one. When I priced this one, he said he needed an AC compressor, and then I researched it, and there was two different ones.
Yes.
The one I priced was like $200.
So get a shot of this real quick, Caleb. Just the front face of this. On this, what Danner's talking about is there's no clutch. So when the belt spins, it's spinning the compressor the whole time. Ours, the front piece you saw wasn't spinning at times, and this piece was. This is one, Danner, what they use in this is the compressor runs all the time. There is no clutch.
It's like a duty cycle.
It's a variable wobble plate.
Yeah, okay.
And so what they do for no air is they keep the plate straight up and down.
Okay.
So the pistons aren't moving back and forth.
Yeah.
And then when you want air, it varies it, and then it spins, and then makes
then
so it's really all the time. There is no clutch.
It's just twice as expensive.
Correct. Twice as expensive. Yep. But I guess they're using that now instead of having an expansion valve. All of your controls for pumping, they would use, I guess. I don't know if it'd be a fixed orifice.
That's your field.
I don't know.
It's
yeah. Anyway, air conditioning stuff. Okay, that's off right now. I don't know if that's on inside or not.
It's turned on.
I know. I heard it.
Pretty loud.
It is loud. What sucks is I gotta make this brake again. All right, I'm gonna keep trying this inside on and off. You stay focused out there on the clutch, and we'll see if we can make this be on in here and off out there. That's what we need. All right, it's on in here.
It's off here.
Sweet. All right, that's what we need. You stay there. Let's see if we can smack on the front of this without getting this wrapped around the belt. This can be dangerous. Just an FYI. So be careful. Okay. Okay. Wait, how many wires I got going to that? Got 2 or 3. Ah, there's 3 there. All right. I don't know what I'm doing. I can't see. Danner, you got an inspection mirror? Nah, screw that inspection mirror. I got a better idea. We have the technology now. I have this awesome camera. I got something cooler than your damn inspection mirror. I don't want your mirror. We're using something fancier. Here, get a shot of this case, Caleb. I'll tell. We're going
mirror.
All right, in case it's cracked too. This is completely overkill for what I'm trying to do. The only reason that I would choose to use this camera right now is because I can show it to you guys better than I can an inspection mirror. Honestly, if I'm not filming right now, the inspection mirror is all I need. I just need to see where the clutch wires are so I can grab a quick power check. That's all I'm doing. So again, for what I'm doing, completely overkill, but we have the technology, so why not do it? Okay, so the clutch, the red wire is actually the clutch ground. Interesting. Grounded up here on this screw. And then the black wire, which comes to this connector with, it's the one I was looking at initially, but there are multiple wires on this thing. Yeah. the heck? There's 3 wires. Why does that plug look like it's not in all the way? So what are the top 2 wires going to? It looks like the yellow wire is going to be my clutch feed. There's nothing there. Maybe it's for an option that doesn't exist on this car. Seriously, it's a 3-pin plug, Caleb, that only 1 wire is being used. See the 3 wires?
Yeah.
There's only 1 wire being used on the other side.
Yeah.
Yeah, it's just weird. How odd, but how cool. Totally overkill.
Okay.
So the yellow wire, at least from what I saw on the camera feed, was connected to the black wire on the other side, and the top 2 wires aren't even being used on this model. So that should be my clutch feed. Okay? And my air is still on. The clutch is not engaged. And just going to battery ground. I'll check my test light, make sure it works. And then I'm just coming over here, and I'm just touching on top of my probe. And it's working, and so like this is about as easy of a diagnosis that you can have, which is we're done. It needs a clutch. There's a ground I can check, but the ground's on the housing, and I showed that as well, and it's a hard mounted ground, so it's only like a little 6-inch piece of wire. That's not going to be our problem. I mean, I can check it, but here's what I'm going to do now. I'm going to go inside, turn the air on and off, and that light should go off. Air off.
Lights off.
Air back on.
Lights on.
That's about as easy as it gets. I know I'm just using a test light, but the fact is I'm getting power to this clutch, and I can do a voltage measurement, but it's really not necessary. A test light is fine. In this case, you'd want to know your test light. That is a pretty bright test light. Let's get a shot here for the naysayers. Brightness wise, I'm going to show it to you here. I don't know if it helps for my hand or not, but I'm going to compare it to the battery itself, just so you guys can get an idea of brightness. Exactly the same.
Yeah.
The only thing that's different maybe over here is I'm closer to the lighting, and so it maybe doesn't look as bright. Yeah, all right. So it's not a voltage drop. So an argument could be, well, I'm not using a voltmeter and we have a voltage drop over here to the clutch. Not the case. I have power. The last thing is going to be, can I get to that ground and show it to you? I don't think that I even can. I mean, we could see it on the camera. I might be able to smack on this clutch again and get it to work. I'm gonna try it. Come down here, we're gonna smack on it again. Now that I know that I have power here, and I'm confident that my ground is not the problem, it's still bolted up. The only way that ground could be an issue is if it was corroded right where it was bolted up to, or if that wire was damaged, and the wire looks fine and the mounting point looks fine. I'm confident in that ground. We'll see if we can check it. Let's try beating on it again.
What is that?
Big giant broom handle. Come on. No. Nope. Nope. Okay, I want to check something else to make sure that I'm right in my wiring before we attempt to hit this ground. Okay, so the plan is two things. One, I'm going to try to check that ground. Two is that 3-pin connector that you guys saw only comes out as 1 wire. I'm going to unplug the connector and see there should be missing pins if I'm correct in my assessment here. Here, real quick, just about the tool. I don't know if you can focus on this screen or not, or maybe just this whole area. Yep. See, I have a front and a side light. I have a front light and I have a side light only. So there's a camera on the side. Look, on the side, and there's a camera on the front. Right now I'm showing the side. So here's the front. Watch. There's the front camera, right? And then I could change that. Here's your side camera, or I could do both, front and side, and then it puts a window down here. So there's your side, right? Right down here at the bottom, side camera, and then top camera. But when you're doing a recording, it only does the big screen. It doesn't record both, which kind of stinks. So that's how, if you're watching, change this in the future and make it record both cameras at the same time when I do record, because it doesn't. So I'm gonna go to the front one. No, there's still 3 pins inside there. I'm gonna take some pictures here, Caleb, because this screen recording's all over the place. Yeah, there's 3 pins on that, but on the back side, all right, so this is side camera view. I'm trying to get the back of this connector. I wasn't able to get it with the front camera. Might be a pressure switch involved here. Nope, there are 2 other wires. Those 2 other black wires wrap around. So I was incorrect. All the wires are being used, Caleb. I was on the right clutch wire. Hang on, let's see where they go. I'm guessing to some kind of probably a pressure switch on the compressor itself. Without a diagram, I don't know. But I was on the correct wire. Yeah, the bottom pin, bottom wires for the clutch. And I was on the correct one. This is critical. I know that it seems like I'm farting around right now, but if I was checking, say, a pressure switch or something and not the clutch, that would be bad. And I need to make sure. I'm gonna pull a diagram just to be sure. All right, let's find my clutch. AC's, that's automatic. This is manual. Okay, yeah. So the yellow wire was the correct one. That's the one I was on.
Okay, good.
It is externally grounded, and I cannot get to that ground. I'm not worried about that ground. This needs a clutch. That all comes part of the clutch anyway. That little short, bitty ground wire. The other 2 valves, they're calling it an electrical control valve. It's some type of solenoid. So that comes in here, blue and gray. ECV in and ECV out. I don't know what that valve does, to be honest with you guys, but that is not needed to engage the compressor clutch. That clutch should be engaged. Just seeing what this electric control valve is. Just trying to get some info here. They don't even talk about it. I'm guessing here with this electric control valve that's on this, it is possible that it is to control a variable displacement compressor. And that information really isn't necessary for me to find. In other words, all we need for that clutch to engage is what we've already done. Power and ground check on the clutch. Of course, checking the ground we can't do, not easily. Check operation of the magnetic clutch, connect the compressor connector terminal 3, that's that yellow wire, to battery positive, and the ground battery negative terminal to the compressor body. Check the magnetic clutch operation noise and determine conditions. So that's it. The other 2 pins are this EVC, the EVC part of it. Measure resistance. So this is what resistance of the compressor coil. EVC resistance may be slightly higher or lower than spec, so they have us checking the EVC. That's AC fuse, feed, check compressor field coil resistance. I just want to make sure I'm not missing something with this EVC. Should be 10 to 11 ohms. I just was making sure that the EVC circuit was not associated with the clutch engaging, and it is not, based on our description we have. It's just checking the circuit's power and ground, and that's it. and this clutch should be engaged, and it's not. So it's gonna need a clutch. Most likely it's gonna get a whole compressor. I was just gonna see if I can get in there to check that ground pin without racking this thing, taking the bottom panel off. I don't think this is happening. I see the red wire right there. I absolutely cannot get to it with that little probing tool. That's if I can get my hand in there. We're gonna stay with the test light. So basically, what I'm looking for, I'm wearing brand new jeans. I'm not laying on this floor. Honestly, it was fine that I had to lift this anyway, because I need to take this panel off to check that ground. I didn't want to do that, but Caleb's right. A lot of you guys will give me crap about it if I don't check it, and I don't think that probe was going to work anyway, so this just forced my hand. We shut the camera off. There was a lot of swearing going on behind the scenes. I'm going to drop this panel, get my probe that I dropped, and then I'll be able to get to that ground. All this to check a ground wire for you guys. Just want to get crap about it. Get the camera. Welcome to... Welcome to being a mechanic. This is what happens. So the screw goes up top. And the whole thing's spinning. All right, you know what? It's fine. It can stay like that. I don't need to be in any further. The fact that it's like this is fine. I have my lead back. Now let's see if we can get to this ground pin. Here's the other two wires that we were debating where they went before. That's that control valve. So just pointing that out to you. The ground pin, the ground connection, it's bolted to the top. Still can't get to it. Can I get my test light there? So this is my feed wire right there. You might not be able to see the tip of where my light's connected. You see the light's lit, right? Yes. That's the clutch feed wire, okay? If this ground is bad, my light's gonna light on this ground too because the circuit's loaded, it's turned on. All right, so I'm gonna move over now to my ground wire and I'll get out of the way. All right, so the tip of my test light's on this red wire, and I'm poking a small hole in this wire. That light is not lit. So all of that work, just to show you guys, something we already knew, which is our ground is not bad. And so theory for us real quick, Caleb. All right, so we have power coming into a clutch coil, just a coil of wire, and then it comes out and it's grounded. Okay, all I've done, put my test light here to ground, test light's lit, nice and bright. Come over here, put the same test light, I'm going to ground, and it should not be lit, it's a ground, right? Yeah. This should be 12, this should be 0. Yep. If the ground is bad, open, so picture that as an open, there will be no drop of the voltage through, and so this would be 12 on the other side. My light would light. Now the thing about the light on this side is it might be a little bit dimmer because we're dropping some voltage through the coil before it comes to the light. Yep. And so this would be a little bit dimmer, but the fact is it doesn't light at all, telling us what about our ground circuit integrity. It's good, your feed is good, your ground is good, we're done. It needs a clutch. Coil's bad. Yep. The key with this is to make sure when you're doing this ground check, because I'm going ground to ground with my light, the key is to make sure that we have power coming in. You can't do this check unless you have power, unless you switch your test light polarity. If I switch my test light polarity to battery positive, then I can just use the light alone and check that ground. Yep. Granted though, the light doesn't draw the same kind of current that the clutch does. And so there would be less of a load on that ground, and you could still have a bad ground, light the light, but not energize the clutch. So there's variables to that. I prefer the method we used, using the existing load coming in, making sure that that circuit stays at 0 volts, not lighting the light, going to ground. That's my preference. But you can do it both ways. Let's try smacking on this thing one more time, now that I have the ability to, with a little bit better, you know, kind of angle. Should be able to make that clutch turn on.
That's really good.
I'm surprised that it worked at all. Where's my pry bar? Screwdriver. Just gonna wiggle the connection up at the top. Nope. Nope. Done. Done. I suppose we could show another check. AESwave, my what is the name of this kit? Is the uTest terminal kit.
Oh yeah.
This is badass. All right, so I'm gonna get a connector that I can put on that. Take my test light to the back of the alternator, which gives me a BAT post. Now when I find a ground my test light lights, I'll let you get a shot of where I am. See where my test light is connected?
Yep.
Right to the back of the alternator. And then my test lead is right here on the housing. And I'm going into the housing with it, into the connector. So I have it unplugged. I'm going right to the compressor feed wire, okay?
Yep.
From battery positive. All right, so here's the test. Test is test light when it finds the ground. So what this test light should be doing is it should be going into the coil. Notice it's not lit at all.
Yeah.
So basically, let me dim this. What we have is an open circuit in the coil. If that coil was good, this light would be going into that pin, it would be wrapping through the coil and going to ground. It would be lit dimly, but it would be lit.
It still works.
And so essentially, this is a resistance measurement, open circuit. Okay, I'm gonna do one more check because I'm now connected to positive, just so you guys can see it. I'm gonna go back to that ground wire, show you guys that this light is gonna light. All right, that's the ground pin. Now I'm connected to battery positive this time with the lead going to the alternator as opposed to ground. Same check, different load, but it's a different way to check that ground. Yeah. It's hard for a lot of people to visualize what a bad ground looks like when you're using the existing circuit. A lot of people want to change the test light to battery positive. It's not necessary when you understand the circuit, but that's just showing you again, our ground is fine. Our feed is fine going in. We have an open circuit. Just showing multiple ways that things can be done. Again, that's going through the clutch coil. One more picture and then we'll wrap it. This final check, what I've done, I've taken the clutch coil, ground's over here, power's over here, but I've disconnected, so I'll just draw that as a connector, right? Disconnected the connector. I ran a jumper. I'm putting my test light here, and my test light's connected to battery positive.
Yep.
And so what I was trying to do is to show you that on a good circuit, we would have power. It'd come through the bulb of my light. It would find a ground through the clutch coil. This is a low ohm coil. So this being a low ohm coil, this light should still be pretty damn bright. Even though I'm going through a resistor, that light's still gonna be pretty bright because it's a low ohm coil. If this was a high ohm coil, that would not be the case. This light would end up being dim, but that's some basic electrical stuff and has to do with pressure between two resistors. Resistor here, and we're essentially, when we're talking about brightness of a bulb, we're talking about how much voltage drops across the bulb. The more voltage that drops, the brighter it will be. And so that's a big factor on this external resistor. Picture this as two kinks in the hose. You got water flowing out of here, Caleb. if I squeeze this one real tight with my hand, what does the pressure do in between?
Increases.
Very good. If I open this up and let go of this, what does the pressure do in between?
Decreases.
There you go. So a low ohm coil, we would have a low number here and a high number here. That's the source. We'd have a large drop. The light would be bright with a low ohm. If I squeeze this real tight and my pressure's high, picture this being 12 volts here. Squeeze that tight, pressure goes up, call it 11 volts. That means my test light, this is my test light. That means my test light only has a 1 volt drop. And so the light would be real dim with a high ohm coil here. Okay. If I use a low ohm coil and let this go, pressure drops. So instead of 11 volts here, maybe we have 2 volts. There's still some pressure left because there's another resistor in the circuit, but 2 volts would mean I have a 10 volt drop for my light, and now my light's going to operate with 10 volts. 12 volts on one side, 2 on the other, 10 volt drop. The light would be bright with a high ohm coil here.
Okay.
Does that make sense?
I think so.
All I wanted to tell you is this test that I'm doing with my test light to battery positive is this light should be bright because this is a low ohm coil, and that's good enough for right now. And for those of you watching this, if you need a little bit more help with this 2 resistors in series and the voltage drops across them, I have some basic electrical classes. I'll post some links in the description of this video. It's on my premium channel. You guys will have to watch those. But that light, what's that tell us, Caleb? The fact that this light is not lighting at all tells you you have an open here, you have an open here, or you have an open here. And we put the test light to battery positive right there, and it lit. So how's my ground?
It's fine.
Yep, and the
open's got to be just somewhere up.
Yep, right from here over, and that's all one piece. And I actually checked it, if you remember, later on, we checked the test light here going to ground, and it lit with the existing circuit when this was all plugged in. So how's this leg of the circuit? Fine. It's good. So where's my problem? I was just pressing on my mic and the paper. That's probably going to be all muffled for that. That's going to suck. Yeah. My open is here. We're done. I know we overkilled that, but trying to teach concepts, we're trying to teach procedures. This is same stuff, guys. 2015 model year car. I mean, I'm still doing the same things that I've done on a 1980 vehicle. This is no different. Yeah, we have a computer that's involved. We didn't even have to go in that direction. These are foundational tests. We will not be showing the replacement of this coil, the compressor. This is a friend of mine. It's going to go back to him. He's going to do the work, so we're going to miss that part, but there's enough information in here for you guys to see without a shadow of a doubt that this needs a clutch coil. And yeah, you guys heard at the beginning, he may have overcharged it too, but I'm putting that back on his lap again as to what he's going to do. Honestly, because he's going to have to pull all the refrigerant out to pull the compressor off and change the clutch, or if he's putting a whole compressor in it. So I don't really need to worry about that part either. Guys, I hope you learned something from this. Caleb, thank you so much for being here, being my cameraman. Have fun in the edits. Guys, thank you. I'll see you soon. Okay.
You have to say something about your glasses.
My glasses? I'm wearing safety glasses. We're not done. What I'm gonna do, I talked to the owner. He'll take these off because I can't see. They're super scratched up. Talk to the owner, my friend, who's gonna do the job. He's gonna see if he can do just the clutch or maybe the compressor. But what we're gonna do for him is we're gonna recover the refrigerant, and that's gonna do 2 things. One, it's gonna take out that extra refrigerant that he put in because he overcharged it. And 2, we'll be able to blow it back in for him and he won't have to buy any new refrigerant. So I'm going to show you guys a real quick recovery process on this, and then we'll be done. I will not be coming back for a follow-up to show you the compressor running. You guys saw the clutch running already. It won't be any different than what you saw. So I don't think it's important to come back for you guys to see a new clutch and see it spinning. That's all you're going to see. So anyway, I'm pretty sure this machine is, yeah, we're missing the covers on the front. This is the machine that used to be here when I worked here. I left this garage in 1996. All right, over here, Caleb. Low side port. The fittings are different too. You see the size difference. You can't really get them wrong.
Yeah.
This is my low side fitting. And then my high side is here. So it's like a quick connect, and then you wind these down, which opens up the valve. And then when I do this one, we'll focus on this gauge here. Now we have some pressure in there already, but this should increase a little bit. And that valve is now open to the machine, okay? Then we wanna open the valves on the tank. And this has a scale, so it's gonna measure it. And we come over here, and yeah, had my glasses on the whole time. I didn't. Now they're on, I'm being safe. We're okay. Turn this on. We wanna keep our hands off it because it's gonna measure it. We're gonna open these up. When we open these valves, that opens the car to the tank, and then all we do is we hit recover. And now it's gonna measure. As it's gonna pull, you're gonna start seeing that these pressures are gonna drop. On both sides, the pressures are gonna drop, and then we're gonna start seeing a measurement. We should start seeing a measurement. In fact, you see the sight glass right here. You see the refrigerant coming into the machine. You see that, and then you see it's measuring the amount we're pulling out. And then, yeah, we'll let that go for a minute. And as far as the type of refrigerant, you can see that it is, even though it's a 2015 model year, it's still R134A, and it's 25 grams. Sorry, it's 550 grams plus or minus 25. I'm not used to seeing that in grams. I'm used to seeing ounces. This is in pounds. So convert grams to pounds for me, Caleb. I have no idea the conversion. So what's 550 grams in pounds?
It's 1.213 pounds.
1.213 pounds plus or minus 25 grams. How much is 25 grams? Wait, hold on. What'd you say that number was again? 1.213?
Yeah. So then it would be plus or minus 0.0551. So
what? What is it?
0.0551.
0.05?
So
that's ridiculous. That's like not even worth putting in there.
1/100th of a.
So it's 1.2 pounds of refrigerant. That's a pretty small number. And I imagine that this is going to be overcharged. We're going to have more than 1.2. Right now we're at 1.18. And we are actually going into a vacuum now on this lower side. So it's almost empty. So it looks like maybe he was a little bit lower. Maybe he thought he added more than he did.
1.25. What was the max?
It's done. 1.25. So he's exactly where he wanted to be. All right, so this is done. We're at 1.25 pounds we recovered from the system. I don't see this being overcharged at all. Now we have the refrigerant for my friend. When he's finished with the compressor, then we'll just blow it back in for him. And I just got off the phone with him. He said this might be under warranty still too, which is pretty cool for him. But that's it, guys. I'm done. I hope you learned something. I think we're officially done this time. Caleb, thank you again. Everyone else, thanks for joining me. I'll see you next time.